Hello dear students, once again welcome back to our channel. In this video we are continuing the theory part of Introduction to Trigonometry. And mainly I am focusing two very important concepts, that is first is how to get the values of some specific angles of 6 trigonometric ratios, and secondly the identity, the basic identities involved in the trigonometry. That will help you to solve the problems very easily. Okay, let's get started children. Okay, for that I have drawn a table, and in the first column I have written this 6 trigonometric ratios, and here the first row, okay, this 5 specific angle. We are discussing only the measurement of these when theta takes these values, that is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Okay, starting with the 0, ending with the 90. In between we have 3 more values. Okay, and I am telling you children, if you know the first row, the values of sine A, sine 0, sine 30, sine 45, sine 60, sine 90, you can easily complete all the entries, other entries, because we know the reciprocal relation, quotient relation. Okay, that is what is quotient relation? That is you can express tan A in terms of sine theta by cos theta. Okay, and reciprocal relation, sin theta equal to 1 by cosec theta. Okay, cos theta is equal to 1 by sec theta, and tan theta equal to 1 by cot theta. Using these two results children, you can easily learn these values without any mistake. Okay, so I am going to fill the first row. Okay, that is values of sine 0. So children, you start with the 0. Okay, that is sine 0. Its value is 0 itself. See children, here angle A. Okay, see in sine A means we are discussing the angle A. Acute angle is A. Okay, that's all. So when that angle equal to 0, that measure of that angle equal to 0, what will be the value of sine 0? That is 0. Okay, 1 by 2 is sine 30, 1 by root 2 is sine 45, and sine 60 is root 3 by 2, and sine 90 is 1. I started with the 0 and ended with 1 in the first row. Okay, so in between these 3 values, you just by heart 1 by 2 sine 30, sine 45 is 1 by root 2, and sine 30 is root 3 by 2. And finally, it ends with the value 1, that is sine 0 is 1, starting with the 0 and ending with the 1. Okay, is it clear children? And those who feel that much difficult to learn this first row, I will give you a trick for you. Okay, instead of this row, I am writing here, you write starting with the 0, 1, 2, 3, 4. See children, this is 0 degree, 30 degree, okay, this is 45 degree, and this is 60 degree, and this is 90 degree. Okay, these are the values. Okay, measure, that is specific angles I have written over here. Okay, 0 to 90 degree, 5 measures. Okay, and in the first column 0, 1, 2, 3, that numbers, whole numbers starting from 0 to 4. Okay, and you divide these 5 entries with 4. Okay, 0 by 4, 1 by 4, okay, 2 by 4, and 3 by 4, finally 4 by 4. Is it okay children? What I did, I just written that numbers from 0 to 4. Okay, whole numbers starting with the 0, and divide that numbers with the 4. Okay, then we can simplify. What will be 0 by 4 is 0 itself. 1 by 4 we can't further simplify, 1 by 4 itself. But this 2 by 4 can be simplified. So 2 and 2 into 1 time 1 by 2 comes. Here 3 by 4, and for sine 90 is 1. And the third step, you just take the square root. Okay, so square root of 0 is 0 itself. 1 by 4 is the second entry, so take its square root. What will be the square root of 1 by 4? Okay, that is root 1 is 1 itself, and root 4 is 2, so 1 by 2. And square root of 1 by 2, square root of 1 is 1 itself and square root of 2 is 1 by root 2. Okay. And sine 60, so 60 degree, take the square root of root 3 by 4. So, root of a by b, children, what is root of a by b? Root of a by b equal to root a divided by root b. I am splitting that square root for both the numerator and the denominator. Hence, it takes root 3 divided by root 4 in the denominator, and that is 2. So, root 3 by 2, okay, and root of 1 is 1 itself. These are the values we got in the first row. Is it clear, children? 0, 1 by 2, 1 by root 2, root 3 by 2, 1. But those who can by heart, that would be better, and those who feel difficult, you can follow these 3 steps. Okay, write down the numbers starting from 0 to 4. Okay, that will fill the first 5 columns 0, 1, 2, 3, 4. Okay, then what to do? You have to divide all the entries with 4, okay, and simplify, then take its square root, and that will give you the first row. That is the values of sine 4 theta equal to 0 degree and 30 degree, 45 degree, 60 degree and 90 degree. That is clear, children? Okay, this is the way you can by heart. And those who know this row and how that other entries can be filled. Okay, that means, children, you just reverse this order. Okay, that means I am starting from sine 90 is 1, that is cos 0. Okay, reverse that order, and this is root 3 by 2, and next comes 1 by root 2, okay, and is 1 by 2, and finally 0. Okay, sine 0 is cos 90. This second row is clear, children. That is how can we complete the values of cos from 0 to 90. Just reverse the order of sine, that row. Okay, that is 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. These are the values of sine. Just reverse its order in order to get the values of cos. Cos 0, cos 30, cos 45, cos 60 and cos 90. It is clear, children? Okay, then when you look into this, children, 1 by root 2 and 1 by root 2 both are the same. Okay, here why? Because which is the we are applying the complementary relation. Okay, that is 45 and its complement is 45 itself. Okay, in the previous video we discussed the complementary relation between this trigonometric ratio, that is sine of 90 minus theta equal to cos theta, children. See, sine of 90 minus theta equal to cos theta, isn't it? If you know this relation, you can easily get it. See, children, here I am taking 45. Sine of 90 minus 45 is 45 degree, that is equal to, here I am taking value of theta as 45, that is equal to cos 45, which means the value of sine 45 equal to cos 45. That is why we got these two values are the same. When 45 degree, when theta equal to 45 degree, sine 45 and that is equal to cos 45. Why? Because complementary relation. Sine of 90 minus theta equal to cos theta. Hope that idea is clear. The same way, children, sine 30 is 1 by 2. Okay, sine 30, we know that sine 30 sine theta equal to cos 90 minus theta. That is sine, here I am substituting theta as 30. So, sine 30, its value is equal to cos of 90 minus 30 is 60. So, we know the value of sine 30 as 1 by 2. So, that is equal to cos 60. See, children, because of complementary relation, okay, you can verify your answer also. Okay, that is sine 30 equal to cos 60. See, sine 30 is 1 by 2. What is cos 60? 1 by 2. The same way, see, sine 60 equal to cos 90 minus 60 is cos 30. Okay, just applying the complementary relation. So we have now the values of sin A and cos A when A takes the value from 0 to 90. We are writing only the specific angles, only 5 measurement we are discussing in this year. Okay, so how can we fill the third column? To get the third column, we are using the quotient relation. What is quotient relation, children? We know that this tan A is equal to tan A can be expressed in terms of sin A divided by cos A. Okay, so in order to get the value of tan 0, you just divide. Okay, this take the value of sin 0. This A must be the same measurement. Okay, divided by cos 0. That is sin 0 divided by cos 0. 0 by 1 is 0 itself. Okay, this is why, because of this quotient relation. Okay, so how can we get tan 30? Sin 30 divided by cos 30. That is, here we have 1 by 2 and root 3 by 2. Root 3 by 2 is the value of cos 60 here, cos 30. So when you divide, see children, how two fractions can be divided? 1 by 2. Take the reciprocal and multiply. So root 3 by 2, its reciprocal is 2 by root 3. So multiply 2 by root 3. So 2 get cancelled. So what is remaining? 1 by root 3. And this is the value of tan 30. 1 by root 3. Hope the idea is clear, children. Why? Because we have this relation, quotient relation, that is sin A by cos A is tan A. Understood? Next is to get the value of tan 60. Tan 60, how this can be? Divide sin 60, that is root 3 by 2, into reciprocal, that is cos 60, that is 2 by 1. Okay, 2 by 1, 2 get cancelled. So root 3 by 1 is root 3. Root 3. Okay, and what is tan 90? That is sin 90 divided by cos 90. Okay, that is what is sin 90? 1 and divided by 0. What is 1 by 0? When the denominator 0, that is not defined. That division is not defined. So not defined. The value of tan 90 is not defined. Okay. Now we can fill the fourth column, cosec A. We have now sin, value of sin for these 5 measures, and cos and tan. And we know the remaining 3 ratios are the reciprocal of, in order. Okay, sin A, its reciprocal is cosec A. Okay, so what is sin A? Sin A is 0. Okay, that is 0 means you can write 0 as 0 by 1. Okay, see children, we know that cosec A equal to 1 by sin A. Because of the reciprocal relation, vice versa, sin A equal to 1 by cosec A, both are the same. But in order to get this row, okay, cosec A equal to 1 by sin A. Here 1 by 0. Okay, cosec 0, 1 by 0. See children, 0 by 1, but not 1 by 0. 0 by 1 is actually 0, and take its reciprocal, that is 1 by 0. And here again comes 0 in the denominator. So cosec 0 is not defined. Okay, that is reciprocal of 0. 0 actually 0 by 1. Take its reciprocal, that is 1 by 0. Okay, so 0 comes in the denominator, means its division is not defined. So cosec 0 is not defined. Tan 90 also not defined. Understood? Okay, now how can we get to this cosec 30? Cosec 30 means 1 by root 2, take its reciprocal, 2 by 1. So 2. Okay, and that cosec 45, 1 by root 2, its reciprocal root 2. Root 2. Okay, and cosec 60, sin 60, take the reciprocal of sin 60, that is root 3 by 2, reciprocal is 2 by root 3. 2 by root 3. Okay, and sin 90 is 1, so its reciprocal of 1 is 1 itself. Reciprocal of 1 and minus 1 are having the same reciprocals. Okay, so reciprocal of 1 is 1 itself. Idea is okay, children? Okay, how can we get the cosec values? Just take the reciprocal of sine because of the reciprocal relation. The same way, either you can take in order to get the sec values, because sec A equal to 1 by cos A. Take the reciprocal of cos, that will give you sec. Yes. So 1 by, its reciprocal is 1 by 1 is 1 itself. Okay, and root 3 by 2, 2 by root 3. Okay, 1 by root 2. Okay, here 1 by 2 is 2 by 1. Okay, and finally here 1 comes. Here in order to get the value of sec 90. Okay, what is 0? 0 means 0 by 1. Its reciprocal is 1 by 0 is not defined. So sec 90 also not defined. And the last entry, that last row, that is cot, we are just applying the same idea, that is take the reciprocal, because cot A is 1 by tan A, reciprocal relation. So I am going to take the reciprocal. What is the reciprocal of 0? Is not defined. Not defined. Why? Because 0 is 0 by 1 and its reciprocal is 1 by 0. That is why. And 1 by root 3, that is root 3 reciprocal. Okay, 1, its reciprocal is 1 itself. And root 3 is root 3 by 1 actually, and take its reciprocal is 1 by root 3. 1 by root 3. And here comes 0 by 1. Okay, that is what is by quotient relation. Cot theta equal to cos theta by sin theta. Quotient relation. Okay, so children, you take the ratio between cos 90 by sin 90. Okay, cos 90 is 0 divided by 1. 0 divided by 1 is 0 itself. Please don't write not defined. That is for 1 by 0. 0 by 1 is 0. That is cot 90 is 0. Okay, we are applying so many results in order to fill this column, that is the values of trigonometric ratios for specific angles. Okay, that is we are applying the quotient relation, reciprocal relation. Okay, and after getting this first row, okay, just take the reverse order in order to fill the second row, that is cos measures, that is cos A, that is 0, 30, 45, 60, 90. So that you can easily get all the remaining columns. This is all about the values of trigonometric ratios for some specific angles. Okay, so the only thing is get the first row, okay, either by hearting 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Okay, or you can apply this trick, that is write down 0 to 4. Okay, 0, 1, 2, 3, 4. Okay, we need 5 values. Okay, and take its divide the numbers with 4 and simplify and take its square root, and so that you can easily get this first row. Okay, and the sign cos A equal to take the reverse order, and next onwards you can write down by applying this quotient relation and the reciprocal relation. Okay, even if this second row also you can fill by using this complementary relation. Okay, that is, what is that complementary relation? That is cos 30 equal to sin 60. Cos 45 and sin 45 both are the same. Okay, and here also see what is it? Cos 60 equal to sin 30. Okay, in that way you can take that idea of this complementary relation for this case also. That is cosec and sec, they are complement to each other. Okay, so anyhow you just learn these values, okay, using these tricks. Hope this idea is clear, children. Okay, see here one more thing, tan 45 is 1, you can see that cot 45 also 1, because 45 is the angle complement to each other. See, you can see that 1 by root 2, 1 by root 2, because sin theta equal to cos of 90 minus theta, they are complement to each other. Okay, here tan and cot, sec and cosec, complement, in the complementary relation they are connected, cos and sin, tan and cot, sec and cosec. Okay, do you remember that one? That is we discussed in this manner, cosine, okay, then cosec and cotangent. Okay, so cos and sine complementary relation, this will help you children. Cos and sine, then cosec and sec, and cot and tan. So all these values will be the same. Okay, that is why cos 45 and sin 45 1 by root 2, tan 45 and this is equal to same. Okay, and root 2 and root 2. In 45 case you can easily by heart. And for the other values also you apply this relation, okay, and apply this one, that is sin theta equal to that complement of the theta is 90 minus theta. Okay, if we need sin 30, okay, sin 30 is nothing but cos 90 minus 30, 90 minus 30 60, okay, that is cos 60. So sin 30, we know the sin value, sin 30 that is 1 by 2 and 1 by 2 equal to cos 60, 1 by 2 equal to cos 60. The same with that idea also applicable for here also. See what is sec 30? Sec 30 you can see that to root 3 by 2. Sec 30 and cosec 60, cosec 60 see. Because cosec, okay, the complement of sec is cosec. Okay, so cosec 60 is equal to sec 30. That hope that idea is clear children. Okay, this is the way you can understand the values of this specific angles of this 6 trigonometric ratios. Okay, our next main topic is trigonometric identities. Okay, in this year we have only 3 basic identities, okay, and that easily derived from this right triangle, okay, and we are applying Pythagoras theorem in order to get into that identities. Okay, yes children, for that we have a right triangle ABC, right angled at B. Okay, for defining trigonometric ratios we need a acute angle, either C or either A. So I am marking that acute angle as A. Okay, so with respect to this angle A, we can define 6 trigonometric ratios. Okay, this is the opposite side. Okay, that side opposite to this acute angle is opposite side, and this is the adjacent side. Okay, and this is the hypotenuse, the side opposite to 90 degree. Okay, this is always you can easily write down, that is this arm is hypotenuse and this arm is adjacent. Okay, for this reference angle, with respect to that reference angle, you can always write this hypotenuse is always the side opposite to 90 degree. Okay, and we are applying this Pythagoras theorem upon this right triangle ABC, and we know that this square of the hypotenuse is equal to sum of the squares of other two sides. Okay, that means sum of the squares of other two sides means this is the AC square, square of the hypotenuse, and that is equal to sum of the squares of other two sides, that is BC square plus AB square. Okay, from the right triangle ABC, okay, by Pythagoras theorem, okay, we will get this result. I am going to divide this equation, okay, both LHS and RHS with the AC square. Let us see. I am going to divide this with the AC square. LHS with AC square means each term we need to divide with the AC square. So whole divided by AC square. Okay, which means we need to divide each term with the AC square. So divided by AC square, divided by AC square. Okay, see, we know that what is A by B, A square by B square is equal to A by B whole square, isn't it? A by B whole square is A square by B square. The same way here I can write this as BC by AC whole square. Okay, plus what is this? AB by AC whole square. And AC square by AC square is 1. Okay, 1. Now look into this right triangle ABC with reference angle A. What is this BC by AC? This is the ratio between two sides of this right triangle, and that can be expressed in trigonometric ratio. What is trigonometry, children? It is the ratio between the sides, that is, we have the 6 trigonometric ratios. Okay, sides of the right triangle. So BC and AC. What is BC with respect to this right triangle ABC with reference angle A? BC is opposite side. BC by AC. AC is hypotenuse. Okay, so BC opposite side by hypotenuse is sine of angle A. Here the reference angle is A. So BC by AC can be written as, this ratio is named as sine A whole square. Okay, plus what is AB by AC? This is also the ratio between the two sides of this right triangle. So AB is adjacent and AC is the hypotenuse, and with respect to this angle A, and this is the cos. Okay, so adjacent side by hypotenuse. So cos A whole square, and that is equal to 1. Here comes a very important result. Note, that is sine A whole square is sine square A. Okay, don't write sine square A square. We are squaring this sine square A. Okay, that is sine square A. The same way, sine A whole cube, sine cube A. There is no change for that reference angle. We are not squaring or cubing, okay, we are keeping as it is, but by taking the square for this ratio, that is sine cube A, sine cube A. Okay, if it is square, it will be sine square A. Okay, we are keeping that measure of angle A without any change. That is why we can write this sine A whole square as sine square A plus cos square A equal to 1. This is the first identity. Hope that is clear, children. How we got the first identity? That is, consider the right triangle, apply the Pythagoras theorem, and we are dividing the whole expression with the hypotenuse, square of the hypotenuse, AC square, so that you can easily reach into the first identity. Okay, from this first identity, okay, you can write this sine square A with respect to this value, sine square A. Okay, from the first identity, children, sine square A can be expressed in terms of cos square A, that is 1 minus cos square A. This is very important result. This we get from the first identity. So you can replace or substitute for sine square in terms of cos square A. That is 1 minus cos square A is sine square A. We learned how to write it tan A in terms of sine A and cos A, quotient relation. Okay, tan A equal to sine A by cos A. The same way we can express sine square A in terms of cos square A. And sine A, if sine square A is this, sine A is square root of this one. Okay, so you can express sine and cos A using the first identity. The same way, in place of sine, if you are keeping cos square in LHS, then what happens? 1 comes in the RHS minus sine square A. When come to RHS, minus sine square A. So these are the very important results which we get from the first identity, that is sine square A equal to 1 minus cos square A, and cos square A is equal to 1 minus sine square A. Is it okay, children? Now we are moving to the second identity. Okay, in order to get the second identity, children, see, in place of AC square, okay, I am going to divide this AC square with this AB square. Another side, we are dividing that Pythagoras result with 3 sides separately. In order to get the first result, first identity, I started with the hypotenuse, that is square of the hypotenuse, AC square. In order to get the second identity, I am going to divide with the AB. Okay, third side, BC. That's all. Okay, so we have AB square, what is it? BC square by AC square. So I am going to divide this with the AB square. Hope that is clear, children. AB square, the whole expression with the same quantity. Okay, so here comes AB square. Okay, so what is the change for the next step? Here AB square by AB square, that the second term get cancelled. Second term get cancelled, that is 1. AB square is plus 1. Okay, and BC by AB whole square. What is BC by AB? Okay, this is opposite side with respect to reference angle A. BC is opposite side. See children, BC by AB. Can we write this as BC by AB whole square in order to get the ratio? So BC and AB opposite by adjacent. What is that ratio? That is tan. Okay, opposite by adjacent is tan. Okay, tan A whole square. Here A represents the reference angle is A. That is why I have written A. Okay, if I mark that angle as theta, you can write tan theta. Doesn't matter. Okay, plus here 1 comes because AB square gets cancelled. Here also you can write AC by AB whole square, right? AC by AB using this result. Okay, A square by B square is A by B whole square. So we have AC by AB. What is that ratio? What is the name of that ratio? AC, that is hypotenuse, and AB is adjacent, hypotenuse by adjacent side, and that is CK. Okay, so sec A whole square. Okay, so I already told tan A whole square is tan square A. Don't write tan A square. Okay, tan square A. We are keeping the angle measurement without any change. So this can be written as, okay, tan square A plus 1 equal to sec square A. Okay, so children, I am writing this in by taking this tan square A to RHS. It will become sec square A, when LHS come to RHS, minus tan square A. This is equal to 1. 1 comes here, or you can write sec square A minus tan square A equal to 1. This is the second identity. Okay. So we have the first identity, sin square A plus cos square equal to 1, and second identity, sec square A minus tan. The ratios are connected by minus sign. Okay, and we got this from this, so this is the first result. Okay, that is 1 plus tan square A equal to sec square A. You can write sec A in terms of tan A. Okay, sec and tan in identity, they are the pairs. Okay, in terms of reciprocal system, sin and cos. Okay, in the complementary, sec and cosec. In identity, tan and sec. Okay, they are coming together in the identity and they form identity sec square A minus tan square A equal to 1, or 1 plus tan square A equal to sec square A. Or can you write it in terms of tan square? If I am keeping tan square here, this one come to that side. Okay, so this is another result, that is you can write this tan square A equal to sec square A, 1 come to that side, minus 1. So these are the result. Okay, tan square can be expressed in terms of sec square, and sec square can be written in terms of tan square. And this is the second identity, that is sec square A minus tan square A. Okay, so this is very simple. You just keep that sec square A. Okay, so minus tan square come to that side, it will be 1 plus tan square A. That is sec square A equal to 1 plus tan square A. And in order to get that sec square in terms of tan A, you take this minus tan square into RHS. Okay, so 1 come to this side, so sec square A minus 1. So this will come to positive tan square, that is tan square A. That is tan square A equal to sec square A minus 1, or sec square A equal to 1 plus tan square, and the second identity is sec square A minus tan square A equal to 1. Okay, now we have one more identity, and that you can easily get by dividing this Pythagoras result. We have divided first with the AC square and AB square, and in order to get the third identity, we are going to divide with the BC square. Okay, so I am going to divide with BC square, here also BC square. Okay, by looking into the figure, BC by BC get cancelled. So we have 1 comes, okay, 1 plus AB by BC, okay, AB by BC whole square, AB by BC whole square, okay, equal to here AC by BC, AC by BC whole square. Okay, I just divided the expression, that is Pythagoras result, with the BC square. Okay, so what is this ratio AB by BC? AB adjacent and BC. Adjacent by opposite side is cot. Okay, so 1 plus cot A. Okay, cot A whole square is cot square A equal to AC by BC. AC is hypotenuse, BC is opposite side by hypotenuse is sine, and its reciprocal is hypotenuse by opposite side. So cosec. Okay, so cosec A whole square, that is cosec square A. So this is the third identity. So for that I am keeping 1 into RHS. Okay, for that we can write from this, that is cosec square A minus cot square A. When this come to RHS, plus become minus cot square A, and 1 will come in the LHS. Okay, see children, you can write x is equal to y as y equal to x. That doesn't matter. Okay, so in order to keep 1 in the RHS for all the 3 identities, that is why I made this change, that is cosec square A minus cot square A equal to 1. This is the third identity. Children, very important, that is sin square A plus cos square A equal to 1, sec square A minus tan square A equal to 1. Here the third identity, cosec square A minus cot square A equal to 1. And from this we have this result. In the same way you can write this. We have now cosec square, in terms of cosec square, that is 1 plus cot square A. Here cot square, if you want cot square A, what can be done children? Cosec square A minus 1. These are the result from this third identity, that is cosec square A minus cot square A equal to 1. This is the original identity, and these are the result from this third identity. Okay, so all the 3 identities we are keeping 1 in the RHS, so that you can easily learn. Okay, and here in the only first identity the ratios are connected by plus, and the remaining 2 they are connected by minus. Okay, in order to get the result, you just apply that transformation, that is, if you keep cosec square alone, this minus cot square come to RHS. So 1 plus cot square is cosec square, that is what is here, cosec square equal to 1 plus cot square. In order to get to cot square, okay, minus cot square come to RHS, so positive, always keep positive sign. Okay, whether it is LHS or RHS, accordingly you can change the side. So minus cot square you take RHS, so positive cot square. Okay, so what is the term there in the RHS? 1 come to LHS, so minus 1. So cosec square A minus 1 equal to cot square A. So this is all about the identities, 3 basic identities and the 2 result from each identities. Okay, so that you can easily solve the problems from this introduction to trigonometry using the identities. Okay, so in identities problem we are applying quotient relation, reciprocal relation, complementary relation. All will help you to solve the problems from these identities. Now we have left with a small topic, that is unit circle. We are familiar with the term circle, and it is a collection of all points in a plane which are at a constant distance from a fixed point, and that fixed point is what we call center of the circle, isn't it? So now we need a unit circle. What is a unit circle, children? It is nothing but, children, a circle with a radius is equal to 1 unit. It can be 1 centimeter, okay, 1 meter, whatever it is. The unit, that is the circle having the radius equal to 1 unit. So we have a unit circle Okay, and I am drawing with the center O, and this is one of the diameter. Okay, I am considering this as a line, that is a number line. So it comes 0. Here it is 1 because radius from this point, I am marking this point as A on the circle, and in this side B, being it is left side, this value may be negative value, but the measurement is being unit circle, 1 unit. Okay, and here also we have an y-axis, another diameter passing through the center. Okay, so here comes -1, here 1 because it's a unit circle. Okay, so radii being remain constant, 1 unit. And now you can see many points on the circle. Let it be A, here it is B, we already marked here, CD are the diameters. And I am marking one more point on this circle, okay, and this side, okay. So let it be P. And I am dropping a perpendicular towards OA and I am joining OP. Now you can see a right triangle, being it is perpendicular towards OA, we can see a right triangle PQO. Okay, will you get that sides of this right triangle PQO using Pythagoras theorem? Of course, children, we can apply Pythagoras theorem. The only condition is that triangle must be right triangle. Okay, now we have a right triangle. So I am asking you, will you get the other two sides, being OP is the hypotenuse. Okay, the 90 degree side opposite is hypotenuse. Will you get the remaining two sides, OP, OQ and PQ using Pythagoras theorem? We can't, children, because Pythagoras theorem has some limitations. Okay, we can get the one side if you know the remaining two sides. Using Pythagoras theorem, you will get one of the side, provided two sides should be known. Okay, but in this case, by using the trigonometric ratios, okay, you can easily get the side. Let us see how that can be done. Okay, and in order to trigonometric ratio means you have to write down, mark any acute angle. The trigonometric ratio is defined for the acute angle also. Okay, so other than this 90, you can mark either O and P as acute angle. Okay, I am marking this O as acute angle and its measurement is theta. What we need, children? We need PQ and OQ, this side OQ and PQ. Okay, and with respect to this theta, okay, this is the hypotenuse because the side opposite to 90 degrees. So this will be the adjacent side. Okay, the arms between the included angle, that is hypotenuse, and this is the adjacent side, and this is the opposite side. Okay, what is the first ratio, children? Sine. Okay, what is sine theta? Here the acute angle is theta. So we can write sine of angle theta. The theta must be acute. Okay, sine theta is opposite side by. Here, children, why I selected sine theta? Because you should select a ratio having one of the side is either OQ or PQ, because we need OQ and PQ, children. So you have to select a ratio having one of the side is the required sides. Okay, so that is why I have chosen this PQ, that is sine theta, that is here, and also this the hypotenuse should also come because its value is known, because 1 unit, it's a unit circle, hypotenuse is also 1 unit. Okay, so that is why I selected the ratio sine theta. Sine theta equal to opposite side, that is PQ, this is the required side, divided by hypotenuse. Hypotenuse is 1, that is POP. Okay, from this sine theta equal to PQ divided by 1, or the side PQ equal to sine theta. So we got the length, the side measurement of PQ, that is one of the side of the right triangle, as sine theta. We know the values, that is some specific angle value we know. So if you substitute, you will get the length of the side PQ. And which is other side? OQ. We need OQ. OQ, for that you have to select that is ratio having one of the side is OQ, and also at the same time hypotenuse also should come. If both are unknown, it will be difficult for us. So for that, here this with respect to theta, this OQ is adjacent side and hypotenuse. So either you can select cos or its reciprocal, that is sec. So I am taking cos. Okay, so cos of theta, cos theta equal to, reference angle is theta, so cos theta equal to adjacent, that is OQ divided by hypotenuse OP. Okay, so OQ equal to, we need this side OQ equal to cos theta divided by 1. Okay, this 1 will come to this side. So OQ equal to cos theta and PQ equal to sin theta. Okay, that is the distance, this OQ is cos theta and PQ equal to sin theta. Okay, this distance is sin theta and this distance is cos theta. This is the way you can find out the sides of the right triangle if it forms it is under the unit circle. And parallel to this, children, we will get one more concept. What can be the coordinates of this P? That is, we have this coordinate axis. Okay, first this is first quadrant, second quadrant, third and fourth. Okay, minus values we have marked. Okay, then coordinates means what are the coordinates? We should get x coordinate and y coordinate of this point P. Okay, for that we will draw a line towards this Q. Okay, and see, children, here in order to get the x coordinate means the distance, okay, of from this point, okay, towards its y axis. This is the x coordinate. Okay, that means this distance will give you, okay, from the y axis to that, how much distance from the y axis to that point, that is what is called the x coordinate. Okay, so that is what we get it as sin theta, sorry, cos theta. So cos theta. Okay, how can we write down the x coordinate is clear, children? Okay, the distance from the y axis to that point is x coordinate, the perpendicular distance. Okay, and in the same way, in order to get the y coordinate, distance of that point from the x axis, that is PQ, distance of that point from the x axis, this I am treating as x axis and this is y axis. Okay, and this distance is y coordinate and that is sin theta, that we have got PQ equal to sin theta, sin theta. So this can be easily get from this concept of unit circle. Okay, so thank you, children, thank you for watching and supporting my channel. So we will meet in the next video with the exercise problems. Okay, so thank you all.